Proteins are non-covalently bonded to integral proteins or lipids, but are not within the bilayer. They rest on the extracellular side. They also help to anchor the cell membrane to filaments of the cytoskeleton.
Integral membrane proteins are embedded in the phospholipid bilayer and act as transporters and channels, receptors, and cell adhesion.
Cholesterol molecules are made of 4-ring hydrogen and carbon atoms. They are hydrophobic and found within the lipid layer with the hydrophobic tails.
Carbohydrates on the extracellular side attached to proteins or lipids make up glycolipid or glycoproteins depending on what they are attached to. They're used for cell recognition. It also cushions and protects the cell from plasma membrane. The phospholipid molecules. The membrane phospholipid consists of a polar head and a nonpolar tail. The polar head is composed of the phosphate group, which forms a region of negative charge bonded to another group that forms a region of positive charge. Each nonpolar tail consists of a long-chained hydrocarbon derived from a fatty acid. The polar part of a phospholipid molecule is hydrophilic. The nonpolar part is hydrophobic.
Integral membrane proteins have a variety of different uses. One is the ligand-gated channel, which acts as a receptor and channel. It opens for inorganic ions such as sodium and potassium when specific signaling molecules bind to receptors on the protein. When the molecules pass through the membrane, they change the electrical charge across the membrane.
Another phase dealing with the membrane, intracellular receptors, are not only just on the cell layers, but also within the cytoplasm or the nucleus. They allow signaling molecules that are small and hydrophobic to diffuse through the lipid bilayer. The receptors are activated by binding with their ligands and interact with DNA to activate specific primary response genes, which can lead to secondary activate other genes.